Welcome to this Unit 7 recap. Remember, we want to take notes on this video, each and every problem. Then go ahead and make corrections to your test, and let's turn both of those into me. Let's go ahead and dive into these problems. So, taking a look at this number one, I went and drew a picture rather than on the test, we didn't have a picture, but we want to basically find the height of the actual car that we have. So we got this model, and you'll notice it is 6 inches by 3 inches. We've got this actual car that's 12 1/4 feet long, and we want to find out how wide it is, or how tall it is, I should say. And so what we need to do is write a proportion, but the thing that we need to keep in mind is that we've got inches and we've got feet. So we're going to need to get these in the same unit, and it really is up to you what you'd like to do. Now, I'm going to go ahead and decide to change this feet into inches, and here's why. If I change these, I'm going to end up getting fractions. But it's really up to you. So you could change this to 3 divided by 12, and this is 6/12. So in this particular case, we end up getting some nice decimals. You'd get 0.25 and 0.5. With that, though, sometimes you may not get a nice decimal, and so it might be easier to change this into inches. So I'm going to go ahead and multiply 12.25 by 12. And here I get 147 inches. So now when I go ahead and write my ratio here of 6 to 147, these two units are matching. And then I'll go ahead and write 3/x. Now we'll go ahead and cross multiply this, so you'll end up with 6x equals 147 times 3, and that's going to give us 6x equals 441. So we'll divide both sides by 6, and we end up with a final answer of 73.5. Now remember, that's going to be in inches. So what we want to do here is put this in feet, because you typically would talk about the height of a car or the length of a car in feet. And so I'll go ahead and take this and I'll divide it by 12. So we have 73.5 divided by 12, and that's going to be equal to 6.125. So the height of this car, go ahead and write that in here, 6.125 feet. Number two, remember that angles in a triangle always add up to 180 degrees. And it says that in this problem that the angles have a ratio of 4 to 5 to 7. So if I was to draw a quick little sketch here, maybe this is the 4 here, maybe 5 here, and 7. And we certainly know that 4 plus 5 plus 7 obviously is not 180. But remember how we can add an x to each of these. So if you multiply each of those by the same number, you're still going to have the same ratio. And so if we go ahead and add those together, 4 and 5 gives us 9, plus 7, we have 16x equals 180. Then we can go ahead and divide both sides by that 16. And we get an x value, which is 11.25. So then what we need to find is the smallest, the medium, and the largest angles. Well, we need to take that and plug it in. So we're going to have 4 times 11.25 for the smallest. We're going to have 5 times 11.25, and then 7 times 11.25. And that's going to give us here for the smallest angle, we're going to get 45 degrees. So right here, this would be 45. Then we've got the medium angle. When we multiply the 5 and the 11.25, we get 56.25. So we'll put that right in here, 56.25 degrees. And then the largest, we end up with 78.75. So right here, 78.75 degrees. And it's okay that we got angles that have decimals. The thing you need to keep in mind is, do these add up to 180? And do they have the ratio of 4 to 5 to 7? And if you were to do some of that arithmetic, you will find out they do. Here, let's go ahead and address numbers 3, 6, and 7 all in one slide here. So what we want to do is name the theorem. Now, the thing you want to keep in mind is that there are 3 different similarity theorems that can be used to show that two triangles are similar. They are angle, angle, side, angle, side, and side, side, side. So let's go ahead and take a look at these situations. Now, if you look at these two triangles, you'll notice that we have an angle right here and here. Then we've got another pair of angles that are congruent. And so as a result, this situation is going to be angle, angle. If you take a look at this one over here, we've got side length here. And if we look over here, I know that this 6 is going to match with the 12. And the reason I know that is because if you look at these two sides, 6 is the bigger of the two, and 12 is the bigger of the two over here. Then I've got an angle here, and I've got another side. And the thing you technically need to check with the sides is, are the ratios equal? So if you write 6 to 12, is that equal to 5 to 10? If it is, and you've got that angle in the middle, then you've got side, angle, side. So 6 over 12 is 1/2. 5 over 10 is 1/2. So we can go ahead and say, yeah, those are definitely equal. And so in this particular case, we're going to be looking at a side, angle, side situation. So then for this last one, we need to notice that all we have are sides. So you need to match them up and check a very similar kind of situation we had in the second problem. So I'll take a look, for instance, at this one, and I've got the smallest side is 3. So I'll go ahead and write 3 over, and then what it corresponds to, the small side over here, is 1. Then I'll go to the next biggest side. So we've got 15, and I match that up with the next biggest side, which in this case is 5. Then is that equal to 18 over 6? And notice that 3 divided by 1, 15 divided by 5, and 18 divided by 6 are all equal to 3. So this is a yes, and the reason that it is a yes is by the side, side, side similarity theorem. Let's go ahead and find a scale factor. So we've got two shapes here. We're going to go from figure A to figure B. So that means that this one over here, this figure A, this would be the pre-image, or the original, and this figure B would be the image, because it says it's going from A to B. So I'm going to go ahead and write that just right above this. So this is the pre-image, and this is the image. The thing you want to keep in mind when we're doing a scale factor is we always want to do the image to the pre-image. And what I mean by that is we're going to take a length and divide it by the length on the image divided by a length on the pre-image that corresponds. So, as a for instance, what we can do here is count one of these sides. So here you'll notice this side here, we've got over 1, down 1. Now, in that particular case, we end up with a length, which would be the square root of 2. Because you'll have 1 squared plus 1 squared is 2. Square root of 2 is the length there. Take a look at this one. We're counting 3 and over 3. So 3 squared and 3 squared will give you square root of 18. Let's go ahead and check now another side. So obviously this side on the left and this one on the left, it's exactly the same thing. So we don't need to check that, but let's check these longer lengths here. So this one here, for instance, I'm coming down 2 and over 2. Okay, so I have the square root of 2 squared plus 2 squared, which is the square root of 8. Notice I'm not simplifying right now. with these radicals. Over here, we count this one off. 6 and 6. 6 and 6 is 36 plus 36, which is the square root of 72. Now the question is, are these two equal? And there's a couple ways we could go about this. But if you're looking to save some time, what you might just go ahead and do is take these and plug them into your calculator. That would be fine. And I'll go ahead and do that in a moment. I also want to show you how we can write these as the square root of 2 over 18 in this particular case. So that would be the square root of 1 over 9. Now if we come over here, you'll notice that this is going to be the square root of 8 over 72, and you've got 8 goes into 8 once, and it goes into 72 9 times. So right away we can see, yeah, those are definitely equal. But if that seems a little bit confusing to you, that's okay. Take your calculator, and let's go ahead and plug each of these into your calculator. So you'll have the square root of 2 divided by the square root of 18, and we get 1/3. Now let's go ahead and check the square root of 8 divided by the square root of 72, and we get 1/3. So that tells us that yes, indeed, these are definitely the same. So it's kind of up to you, how you want to go about all of this, but these are going to be the scale factor. So when we do that, we get that 0.3 repeating. We end up with a scale factor of 1 to 3. We have the new divided by the old, the image divided by the pre-image, because we're getting smaller. And just real quick, take a look at this. If you were to square root the 1 over 9, that is equal to 1/3. The square root of 9 is 3. The square root of 1 is 1. Okay, so just kind of keep that in mind. All right. Let's take a look here at solving a proportion. So remember, this is where we want to cross multiply. So I'll have the 12 times the 2x plus 4, and that's going to be equal to 9 times 3x. So now, let's go ahead and distribute that 12 to the inside. So we have 24x plus 48 equals then 27x. Let's go ahead and subtract that 24x off of this left side. And there we're going to get 48 equals 3x. We'll divide both sides by 3, and we get this 3 to cancel out, and we get x equal to 16. Let's go ahead and write a proportion to solve for a length of a side. So it says that we're trying to find OL. So here's OL. We've got two shapes that are said to be similar. Notice that the O and L are the fourth and the first letter. So that means that DA is corresponding to that. So that's going to be the 17. So what I'm going to do is I'm just going to go ahead and throw an X on there so that we can have a variable to solve for. So now I'm going to figure out, okay, what am I going to do for my ratio? So let's go ahead and write that 6 over the 4.5. You've got AB, which is the first and second letter, LM, which is the first and second letter. So we know those go together. So we have 6 over 4.5. Then I need to write the 17 on top, and I'll write the x on the bottom. So now at this point, we can go ahead and see that we've got a ratio and another ratio, and the 6 and 17 come from the same figure, and the 4.5 and x come from the same figure. So we've got our proportion set up correctly. Now let's go ahead and cross multiply. So you're going to have 6x equal to 17 times 4.5. And when we do that, we end up with 6x equal to 76.5. So now we just need to divide by 6, And that's where we're going to get our x from. So we get x equals 12.75, which is the length of OL. Okay, this numbers 9 and 10 are going to be referenced by this problem. So these two problems basically are combined into one. And so what we want to first do is identify the similar triangles. That's the first thing we got to do. So if we go ahead and just name this triangle on the left, for instance, we can name it really whatever we want. Just make sure you use these three letters. I'm going to go with XYM. And that's obviously not the only name I could give it. I could say XMY, I could say MXY. There's lots of different examples there. But once I've named this first one, I need to make sure that I correspond each letter with its corresponding letter in the other name. So X, you'll notice, has one arc in it. That means it goes with this Q. So I'll write Q first. Then notice I went to the Y, which had the double arcs. So I need to do the same thing over here. So I've got the R. And then, of course, we're left with the M, because M is going to correspond to M because it's one point right there in the middle. So now we need to go ahead and solve for X and then find the length of YX. So we can clearly see that the 4x plus 1 is going to go with the 10. And we can also notice that by looking at the names. So we get XY, first and second letter, QR, first and second letter. So we're good to go there. So we'll go ahead and write 4x plus 1 over 10. Then you're going to have this 12 goes with the 6. Just again, make sure that you put that 12 on top because it comes from the same triangle. If you'd like, you could even simplify this 12 over 6 to 2 over 1 if you want to make that a little bit easier on yourself because it'll be, smaller numbers, but it's really up to you. So I'm going to go ahead and just keep it as a 12 over 6, and I'll have 6 times 4x will be 24x. 6 times 1 is 6, and I have 10 times 12, which is 120. So I'll go ahead and subtract the 6, and I'll have 24x equals 114, and then we get an x value, which is 4.75. And it also says to find the length of xy, or yx. So I need to take that 4.75 and plug it in. So I'll have 4 times 4.75 plus 1. That's going to be equal to yx. And when we do that, we end up getting 20. Let's go ahead and write another proportion here. You'll notice that we're given that we have medians. So this BD and QT are medians. And remember, what that means is that the D would be a midpoint of this AC, and the T would be a midpoint of the WR. So just kind of keep that in mind. But when that occurs, it gives us the ability to write a proportion. And so what we can do is we can match up the 5.5 with the X, and then we can match up the 12.5 with the 9.4, and then solve. So let's go ahead and do some cross multiplication. So we'll have 5.5 times the 9.4, and that's going to be equal to 12.5 times x. So then when you go ahead and multiply the 5.5 times 9.4, you get 51.7 and 12.5x on the other side. So we're going to divide by 12.5 on both sides. And when you do the 51.7 divided by 12.5, we end up getting an x value, which is equal to 4.136. And notice that x value is also the length of Q to T. So 4.136 is our answer there. Taking a look at number 12, we want to find the measure of angle A. Now it says that these two triangles are similar. So if they're similar, then that means that this angle over here would also be 24 degrees. Because notice the D and the C correspond to each other. The angles have to be equal. And if this M is 108, that means this B also has to be 108. So we just need to find that third angle. We need to find the measure of angle A, but either one you find is totally up to you. So we're going to have 108 plus 24 plus the measure of angle A, and of course those are going to add up to 180 degrees. So let's go ahead and add these together. So you're going to have 132 plus the measure of angle A equals 180. And we can subtract that 132. And so we're going to end up with the measure of angle A. Let's go ahead and write this 132, subtraction on both sides, that'll cancel. And so then that's going to give you 48 degrees. So we get 48 degrees for that measure of angle A. Now these kinds of problems here can be a little challenging sometimes. One thing that is a possible idea that you could do is redraw these two triangles, and so you can see all the corresponding sides. So what I'm going to do is I'm going to go ahead and do that. I'm going to trace this side of that triangle, rather, and I'm going to go ahead and write the lengths, and we could make it a little smaller if we need to because we don't have enough room, you know. So I'll just go ahead and make that a little smaller, like so. And I'm going to write the corresponding lengths on there. So we've got the y, we've got the 14, and then we've got the 10. Okay, so that's that smaller triangle up top. So now let's go ahead and do the other triangle. And I'm just, just a quick sketch, and you can just do this down there, on your piece of paper. I'll make this a little bit smaller so we can get this a little bit better. Okay, so that's the bigger triangle. So now we've got here this big side. That's going to be the 14 and the 7, so that's going to be 21. We've got this x down here, and then this side is going to end up being y plus 6. So the only ratio that we actually have here is 14 to 21 that's complete. So we can go ahead and write that and then write it in conjunction with the other one. So we need to find y. Now here's the other thing that you could take a look at. You'll notice that we've got this 7 to 14. So we could go ahead and just notice that this 14 is twice as big as the 7 to find the y. That makes things a little bit easier. So if you do notice something like that, you could do it. If you don't see that connection, then you're just going to have to split up the triangles and do what we're about to do here. So regardless, it's a good idea to split the triangles up for this bottom part, this x. So I'm going to go ahead and just notice, hey, this is 12 right here. So then I can go ahead and fill that in over here on this part and then here. So I've got 12 there. And then over here, this will be 12 plus 6. Well, that's going to be 18. So let me go ahead and also erase that and put 18. So I do have the y, so that's 12. Now I got to find the x. So again, I would go ahead and go 14 to 21. And then we could go 10 over x, and then cross multiply and solve. And when you do that, you end up getting an x, which is equal to 15. Number 14, let's go ahead and set up a quick proportion. We've got an angle bisector, which allows us to say something like x to 7.5 is equal to 13 to 16. So let's go ahead and cross multiply. So we'll have 16x equals 13 times 7.5. And when we do that 13 times 7.5, we end up getting 97.5. So we have 16x equals 97.5. We'll divide both sides by 16. And we end up getting kind of a long decimal here, but that's okay. It is exact, so 6.09375. And that's an exact answer, so I'm going to go ahead and just leave my answer like that. No need to round that. If it does ask you to round on a particular problem, we could round that to 6.1 or maybe 6.09, something like that. Number 15, again, these are all very, very similar to each other, these problems. And so because these sides are parallel to each other, it allows us to write something along the lines of 3 to 2x plus 1 equals 3.75 to 6.25. So you have top to bottom equals top to bottom. So then I can go ahead and, again, cross multiply like we've been doing. So we've got 6.25 times 3 equals to 3.75 times 2x plus 1. So we end up with, over on the left here, 18.75, and then on the right side we're going to end up with 7.5x plus 3.75. So we'll subtract that 3.75, and we're going to end up with 15 equals 7.5x, divide by the 7.5, and we end up with x equal 2. Let's go ahead and perform a dilation on this. So it says that we're going to do a dilation centered at the origin. So here's the origin right here. A scale factor of 3. So I'll just go ahead and write that down. This is going to be 3 times as big. And we're going to do that to triangle ABC. So what you just need to do here is identify each point and its distance from the origin. So let's start with A, for instance. Notice this one is to the left 2 and down 1. So you want to think about left 2, down 1. What's 3 times is that? Well, that's going to be left 6, down 3. Or the other way you can look at it is you can go left 2, down 1, and then do that 2 more times, which will be a total of 3. So this is where we're going to end up getting our A prime. So for the B, I go to the right 2 and up 1. So I'll go to the right 2 up 1 and the right 2 up 1. That's a total of 3 right 2s up 1s. And we get B prime. And the C is right 2, down 2. So I'll go right 2, down 2 again, and 1 more time to make a total of 3. And then I can just go ahead and connect those up. One thing that you always want to check is, are the new sides parallel to the old sides? And you can see that they are in this case. And finally, we have a proof that we need to take care of. So in this particular proof, we've got that AB is parallel to DE. And of course, that's the given. Now we want to prove that triangle ABC is similar to triangle DEC. So the question is, what do we fill in the in-between? And then what's our reason for that? Well, remember, when we have parallel lines, we often then, as a result, have congruent angles. So if you take a look here, because these lines are parallel, the A and the D are going to be congruent. You also can notice that the E and the B will also be congruent. And that's enough to say that these two triangles are similar because by the angle-angle similarity theorem. You could have also brought in the vertical angles if you'd like. So that's up to you. You don't need to because we just need angle-angle, which is 2 angles, but it's really up to you how you want to go about this. So I'm going to go ahead and go with the angle A is congruent to angle D, and these are alternate interior angles. I'm going to go ahead and go with the vertical angles. That was something that came up on the test, so let's go ahead and write that in. So I'm going to call this angle up here angle ACB, and over here I'm going to call this angle on the bottom DCE. Remember, I've got to use 3 letters because we've got multiple angles occurring at the same point. And these are vertical angles. So then our reason for this, then, that these two triangles are similar will be by angle-angle similarity. All right, I hope this helps you with your recap on your Unit 7 test. Have a great day. Get those corrections done and turn in your notes from this video and those corrections.